we are going to be running through the Python refresher for this course, right? So it'll be mostly in Python like we did in the last class, but let's go to it. Firstly, you need to download this file, right? It's a .ipynb file. So it's a notebook, a Python notebook. So once you've done it, you just say you have to go to this website. It's Colab. Let me actually do it all over. So colab.research.google.com, and you say upload. And then when you upload, you choose the file that you downloaded, which in this case would be this one. And then you upload it. So just because I'm using Safari, I can just do this since it's already in my downloads folder. But it doesn't matter. Just do it how I showed you. Upload the notebook, and it's gonna take you straight. It's gonna open the notebook for you, and this is what you're interested in, right? So we're going to. This is a notebook, and sorry about that. I just got a phone call. I just put my phone on silent. Okay, anyway, so this is a notebook, and the code is run sequentially. So when I click run, this is the run button. It only runs this, right? And then now I have to run the next line. So if I haven't run any code, it's like it doesn't exist. It's just text, right? So let's look at what it's doing. The first line says import numpy. So the library we use for matrices, right? In math, you have matrices. To represent that in a computer, we mostly use this library because it's very quick, and it makes it easier to work with arrays from a computer. So you import that module, and then as np means we're going to reference that module's name with the string np. So not a string, sorry, with np. So when I say n, instead of saying numpy dot something, I just say np because it's very short. I don't have to be typing numpy all the time. Okay, and the next line says a equals np dot array. So this is just an array, right? So look at this comma. This comma is separates the columns. I mean, sorry, the rows. So this 2, 3, 4 is one row, and then you stack another row beneath it, 6, 7, 8. If I added more rows, for example, if I said 4, 3, 2, run it, and you'd see it added a third row. And then d type equals int just says the data type of each of these things is a string. I mean, sorry, is an integer. So remember we spoke about strings, right? So if I made this 7 a string now, right? Look at what's gonna happen. It's no longer a string because I said everything in here has to be an integer, right? So if I removed this now, for example, and ran it, you see it mixes up the data type because it sees there's a 7 string, it sees there's an 8 integer. So just keep that in mind, that sometimes it's necessary to force it, but don't think too much about that. For now, just know that it just sets the data type of the array to be a string. Then look at this. So I create a variable b, and I say np.zeros 2 3, and then when I say b, I'm just saying, okay, cool, tell me what b is. So it becomes an array with 0 0 0 0, and this 2 3 just specifies the rows and columns, right? So np.zeros says, okay, from numpy, which remember we imported numpy as np, so that's why we reference it as np.zeros. Create an array of zeros with dimensions 2 by 3, 2 rows and 3 columns. You can say 2 rows and 3 columns. And now c equals np.ones. So remember we did zeros, so now this becomes ones. We're now saying, okay, cool, create an array with ones instead of zeros, and it has to be a 2 by 4 array. So 2 columns, two rows and 4 columns, and we're making it a type int. So remember, let's try int. Sorry, it's a float. Let's try int. What's gonna happen to the data? They become integers. You see, the comma, the point, and the decimal points all go. But when it's a float, it's sort of like, just think of it as a decimal, for now, but you still figure it out as you do more stuff. So we say, okay, create an array of ones with dimensions 2 by 4, and the data type in each array is a float. And then C just says, okay, show me that array. D equals MP dot arrange 2 and 10. Okay, sorry about that. Okay, anyways, so D equals MP dot arrange, right? So what we're saying is, give me the range of numbers from 2 to 10. But something in Python is you do not include the last number. So if I wanted to have a 10 there, I'll just press it here. So now I've got a 10 in it. If I see earlier it was a 10, so you won't get a 10, you'll only get a 9 in it. Okay, I'm just going through some stuff here. Okay, cool. Let's go to the linspace now, right? So the only thing linspace does, it says, okay, cool, right? Between the range 0 to 1, right? Divide it into 30 different, sections. So divide it into, find numbers between 0 and 1 that are evenly distributed. Like the difference between the numbers is constant, right? And there has to be 30 of them. So you can see if you count these, there will be 30 and ends at 1. So it goes from 0 to 1 and there's 30 of them in it. Just 1 second. Someone is knocking. I'll be here in 2 minutes. Just give me a minute. Okay, sorry about that. Now NP the indices. So for now, just think of it as it represents numbers, like, when you say 2, you're saying the number of rows, right, has to be 2, and 6 just says that, the range you're going is from 0 to 6. And remember, we don't include the last number. So it's going to create 2 arrays. The first one will be between 0 and 1. And okay, think about this. What if I put a 3 now? You see, it's now 3 rows. So let's go back to the 2. So np.indices of 2 rows and 6, the range 6. So you have 0 to 6, and you don't include 6 because that's how Python works. Okay, anyways, so a dot shape, right, gives you the shape of the matrix A. Remember we defined A, so A looks like this. So obviously we know A is a 2 by 3 matrix. So when I say A dot shape, it says 2 by 3 because that's the number of the shape of the matrix. A dot n dim gives it the dimensions of A. So in this case, A is 2-dimensional, right? Because you don't have, it's a 2 by 3 matrix, right? So if I put a 3 by 3, it's gonna change. And then A dot d type is int, means the data in A is an integer of 64. Because remember we specified it here that the data type of A is int. So this is confirming to you that it's actually an int. Okay, for this part, right, I'm not going to go through it, but I want you to run all the code here and understand the maths and how the maths, actually integrates into your code. So, using your knowledge of linear algebra, everything has already been explained here, right? Just run the code, make sure you run each and every single code and understand the mathematical relationship. Because you already know these things. Here we're just trying to teach you how it translates into computer. Okay, so now this is matplotlib. So this is just a library that plots that you use to plot data, draw graphs, histograms, and all that. And the way you get it is you say import matplotlib.pyplot as PLT. Remember, when we call it PLT, it means this is not a reference for this library, right? So to draw this thing in matplotlib, this is the code. Once you run this block, it runs whatever is here and shows it. You see, name PLT is not defined. Do you know why? Because I haven't run this, so it doesn't exist. So once I've run this, it now exists. Now when I run it, it's now defined. So x equals this between 0 and 3. So we're saying we want 100 evenly spaced points between 0 and 3, right? And then y becomes np dot sine x. So for each of those 100 lines, find the sign of it and put it in a new array called y. And then x label, we're just naming these. Here's the x label, and there's the y label, and then we're plotting x and y, and this is what we get. Okay, so you can sort of look at this code. It's sort of the same thing, except the designs are sort of different now. See, there's a red star and the blue star. See, this for Mark and this for Sam. So this is Sam and this Mark. So Sam got a red star, as you can see. So you just play around with this code, right? This will be very important. Another very important one is a scatter plot. Okay, cool. So we generate x data, and then we just say y equals np.random.rand. So we just get in random data, and then z is equal to another random data, 20 random points, and then we're saying okay, cool, plot x to y, because remember x is the input and y and z are outputs, so we'll have to plot it twice. See, so first we plot x with y, and then this is just design and a lot of things, you know. You don't really the specific. You could do it in many ways. So you really Google is your friend basically in terms of design. Now we make another one of x and z, and all of this is still in the same graph. We gave it different names. Now we put a legend here in the y limb. So y goes from -2 to 1.2, -2 to 1.2. Python the show just says, okay, show me the graph. Okay, next thing, n equals 10, data equals np dot random label. So just go through all of this, right? You'll understand it line by line if you read it. You don't really need to understand every single thing, just sort of screen through it, because you know the most important thing is that you understand the maths behind it. A histogram, for example. So those are histograms. So please go through all of this, because I think you can be able to do it up using the same way that I went through the earlier ones. Bar charts. Okay, yeah, it's the same thing. Now let's go to the SciPy module. So SciPy is an extension of the NumPy package, collection of mathematical algorithms. So yeah, it's not like NumPy. I mean, it's sort of like NumPy, but it is more advanced methods. For example, the integral. If I want to compute the integral from 0 to 1 of this, right? So right now we are just importing, right? So we imported SciPy.integrate. This is what we actually use to integrate, and then we going into the integrating thing, because it's saying from this import that. So get this from that. So there's a library called the module called a library called quad, and it's located here. And then we define this function here. So 2 times np dot exponential, it's 2 times e raised to the power -2 1 j dot times np. So by the way, j is this I, it's in NumPy it's written as j, NumPy t, between 0 and 1. So yeah, you can also find integrals of oh, by the way, this is the answer if you didn't notice. So that's the integral. Then this is the error. So it's saying, okay, this is the answer, plus minus that. Okay, and this is an ODE. So to solve an ODE, this is how you do it. Lambda y, comma t, and then y, and then 1, and then np dot linspace. So you like solving the ODE over this interval. And then for each interval, right, for each stop, this is the actual result. Because remember, the linspace has to have 10 points, and that's um, the actual range that you need to solve it over. Oh, and another important thing is interpolation. So in interpolation, just say, okay, given certain points, right, just draw a line that passes through every single point in the data. So these points here, interpolation just draws a line that passes through all of them. So look at this. So this function, this new univariate spline interpolation is good when the data, for example, look at this part. To interpolate normally I would have gone here, then here, then here, then here, then go back. Then it's not continuous anymore. You see? So this just makes sure the interpolation is continuous. And another thing is Fourier transform. Remember, if you do PDEs, you probably come across a Fourier transform. So it's a way of like converting a function from a function of, we're changing the function to an integral in a way that it's reversible all the time. So that's very helpful. So to compute this, the Fourier transform is that, right? This is the way you do it. Just run through this code, right? I'm pretty sure you'll be able to understand it. It's necessary for you to do stuff yourself and run code yourself and actually type things, try new numbers, move around. Okay, so there's a two-dimensional Fourier transform. And this is what we get. Okay, curve fitting is a way of, just sort of like regression, you know what I mean? So let's say we just get 10 points, right? Between 0 and 10, and we get y, right? Now look at this y, right? If you used interpolation, the strict one, you literally have to go through each of these points, right? But then we just see there's a general pattern and there's the best fit. So this, what it does is it finds the best fit for your data that you're getting. And there's many ways to do it, like the least squares regression and other more advanced methods like gradient descent, a lot of other methods. But that's not really important for now. For now, just learn that these things work, try them around, and run the different codes. So here's the place where the least square regression is actually used. Okay, so just go over this yourself. Make sure you run through your code, and I'll see you in the